So there are three ways to solve systems of equations. The first method we learned was graphing. To graph a system of equations, you have to graph both lines and look to see where those lines intersect. Graphing is a fine method to solving systems, but it's not the most effective or efficient way because you need graph paper, you need a ruler, you need to make sure that your lines are accurate, you need to make sure the answers are not fractions or decimals, which is more like me. I need to set up questions that don't have fractions or decimals as answers because you can't graph them and estimate what the point would be because it wouldn't be an accurate like 2, 1. So it's not the best. Yesterday we learned solving systems of equations with substitution, and that is a great method that you can solve just using algebra. And today we're going to learn the last method, solving systems using elimination, which is another method using algebra. Both of these can be used every single time. I do want you to understand how to do both of them because the way that problems are set up will change depending on what method you want to use. Sometimes one method will be easier than the other. Systems of equations using elimination problems, they look like this. So when we have a substitution problem, the first thing we would do is look at the equations here and take one of them and solve them for y or x, and then use substitution, replace, and then solve. So for systems of equations with elimination, you don't actually have to solve anything. You prefer to actually have your equations set up like this. This setup is called standard form. Standard form equations have a number in front of x plus a number in front of y equals a number. So technically it looks like this, ax plus by equals c, where a, b, and c are usually integers. And when you have elimination problems, you want the equations to be set up like this. So the way that they are currently is exactly what you would want for an elimination problem. Elimination, the actual word eliminate, means get rid of. And what happens in this method is you get rid of one of the variables. You do this by either adding or subtracting the equations completely from start to finish. So what you're doing is you can draw like a line here as if you were taking this whole entire thing and adding it or subtracting every single term. So what I'm going to do is actually add these ones, because if we add these straight down, we're going to see something happen. And what happens is elimination. If I add 3x plus 2x, that's 5x. And look what happens here. If I add 1y plus negative 1y, what happens to the y's? They cancel out. They go away. That's called elimination. 3 plus 7 is 10. So what happened here, which it was set up exactly to do that, is that when I added these equations straight down, the y's ended up canceling out. And they did that because we had 1y plus a negative 1y equals 0. Now, if we just go ahead and solve this equation, we know that these two lines cross when x is equal to 2. I know that every single solution to a system of equations is an ordered pair. So right now I know that 2 is the x coordinate of the ordered pair. Now we have to solve for y. When we're solving for y, we actually still have to use the substitution step in that we have to choose one of the original equations. So we can either choose the first or second. I kind of like the first one better because it's all positive. So I'm going to take the first equation, 3x plus y equals 3, and I'm going to replace what we just found x to be in for x. So 3 times 2 plus y equals 3. Then I would solve for y. 3 times 2 is 6. Subtracting 6 from both sides, I'm going to get that the y coordinate is negative 3. So I know that these two lines intersect at the ordered pair 2, negative 3. Just like you could before, you could then replace 2 in for x and negative 3 in for y and make sure it works. 3 times 2 plus negative 3, that equals 3. 2 times 2 minus negative 3 is going to be 4 minus negative 3, which is 4 plus 3, which equals 7. So we're good. It works for both. Now this one was set up exactly for the elimination step to happen. Because we had a positive 1y here and a negative 1y here. It doesn't always have to be 1 though. This could have said like 3x plus 2y equals 3. And 2x minus 2y equals 7. Anytime you have opposite coefficients and you add straight down, they're going to cancel out. And that's what you want to happen. But not all of the time will that happen. Only the easy problems that are set up that way, it will happen like that. So if I look down the next question, and I look at the system of equations I have here, I have 4x minus 5y equals 13, and 3x minus y equals 7. If I was to just take these two equations and add them, would anything eliminate? No. 4x plus 3x is 7x. Negative 5y plus negative 1 more y is negative 6y. That doesn't help us. The only way elimination works is if one of the variables will eliminate. If not, then you're just adding two equations together and getting an equation that is the two added together. It doesn't help. So when we have problems like this that are not set up so that elimination can already happen, you have to use multiplication to take one or two of the equations and multiply everything in that equation to get it so that things will eliminate. So what you're doing is you're looking at all of the numbers in front of your variables. These numbers are called coefficients. So the number in front of the first x is 4. The number in front of the second x is 3. The number in front of the first y is negative 5. The number in front of the second y is negative 1. You have a lot of options here. You can either cancel out x or you can decide to cancel out y, but you're going to want to try and figure out the quickest way to do this. And looking at x and y, one of these variables is actually easier to eliminate than the other because you would only have to multiply one equation. If you eliminate the other one, you have to multiply two equations. Which variable is easier to eliminate in this one? Yes. Y is the easier one to eliminate, and that's because I can take the second equation and I can multiply it by either 5 or negative 5 to cancel out with this one. Your whole goal is to take these equations, so I can take the second equation here and multiply it so it either looks identically to the first one or the opposite. I prefer to have opposite coefficients so that I can add the things together for them to cancel out. And because this is a negative 1y and I want it to turn to a positive 5, I would multiply every single term here by negative 5. So I'm taking 3x minus y equals 7 and multiplying every number by negative 5. When I do that, the second equation becomes negative 15x. Negative 5 times negative 1 is a positive 5y. Equals negative 5 times 7 is negative 35. So what I did was I took that second equation and made it negative 5 times larger by multiplying every term by negative 5. The biggest mistake I see is that students don't multiply every single thing by the number. They might just do the first or second and they'll forget the number on the right-hand side of the equal sign. When you multiply, you have to multiply every single thing by the number that you are multiplying by. So now instead of using the original two equations, I'm going to use the first original equation, the 4x minus 5y equals 13. But then I'm also going to use this second one that I just created, the negative 15x plus 5y equals negative 35. So the reason why I decided to multiply by that exact number is because now I have opposite number of y's here. I have negative 5y and a positive 5y. So if I take these two equations and I add them straight down, I know that the y's are going to eliminate. Sometimes x's will eliminate, sometimes y's will eliminate. In this case, the y's will eliminate. Now I will do 4 plus negative 15, that gives me negative 11x, equals 13 plus negative 35, gives me negative 22. Once you do the elimination step, it should be very simple because half of the equation is going to go away. Now we're left with a simple one-step equation. We get here x is equal to 2. Now I know that my solution is going to cross at 2 on the x-axis. Now it's time to solve for y. To solve for y, all you need to do is pick an equation. You have a bunch of equations to use. I like to choose one of the first equations up here before I multiply. I don't know, I kind of like the first one better, 4x minus 5y equals 13. It doesn't matter which one you use, but I'm going to use the first one. And since I found that x is equal to 2, I have to use substitution again, like we would do before, but I still do that step like we do in the whole substitution type of problem by substituting 2 in for x into that equation to solve for y. So 4 times 2 is 8. Solving this equation for y, I would then subtract both sides by 8. I'm going to get negative 5y equals 5. And then when I divide by negative 5, I'm going to get that y equals negative 1. So I know that my solution to this system is 2, negative 1. These two lines cross at the ordered pair 2, negative 1. Just like we could before, we could take 2, replace it in for x, take negative 1, replace it in for y, and make sure that it works. 4 times 2 is 8, minus 5 times negative 1 is negative 5, and 8 minus negative 5 is 8 plus 5, which is 13. It'll work for both of the equations. Now, I decided to do elimination by eliminating the y's there, but that is not the only option. So what I'm going to do is clear this whole problem out and do it again. But now instead of eliminating y, I'm going to eliminate x. It does require more steps because I have to take the equation and multiply it by, I have to take both equations and multiply it by a number. So now I'm going to eliminate x. So I have 4x and 3x. I can't just take one of these x's and multiply it by a number to turn it into the other one. Like I can't take 3 and multiply it by like 2 to make it turn into 4x. So I have to think of the least common multiple of 4 and 3, and that is the number I need to get both of those numbers to be, if that makes sense. What number am I talking about? 12, yes. So you don't have to write it down. You can just follow along. I need to take these equations and turn one of these to be positive 12 and the other one to be negative 12. Well, I'm going to take this first one. I'm going to multiply it just by positive 3. So the first one will be a positive 12. I'm going to take the second one and multiply it by negative 4 so that that one's the negative 12. When I do that, I multiply literally every single term by the number I'm multiplying by. So I multiply 3 times 4x, that's 12x. 3 times negative 5y, that's negative 15y, equals 3 times 13, that's going to be 39. For the second one, negative 4 times 3x, that's negative 12x. Negative 4, be very careful, negative 4 times negative 1y is going to be a positive 4y. And negative 4 times 7 is negative 28. Now that I've done that and I multiplied 2 equations, which just takes a little bit more time because I have to multiply both of them instead of 1, now when I add straight down, the x's will eliminate because I have one positive 12x and one negative 12x. And then when I go ahead and do this, the same exact thing is going to happen as before. Negative 15y plus 4y is a negative 11y, and 39 minus 28 is 11. When I go ahead and solve here, negative 11 divided by negative 11 and 11 divided by negative 11 on both sides, I get y equals negative 1. Just like we did before, but now we're doing it backwards. Now we have the y variable first. Then we would take negative 1, replace it in for y, and then solve for x, and we would still get 2. Was it 2? We would still get 2. We would just have to do it backwards. Okay? So that's how that works. It depends on how you would like to solve it and what you want to solve for. So looking at letter C, which you guys are going to try on your own. Letter C, there is not just one easy way to do it, because if we're looking at the coefficients, 4 and negative 3, I can't just multiply one to turn into the other, so I have to multiply both of them. And same thing for this one, negative 3 and 8. I can't turn negative 3 into 8 either. So what you would have to do is decide if you want to cancel out your x variables. It'll be very similar to the first one because the number you're looking to get them to be would be 12 or negative 12. If you're looking to eliminate y, then the number you're looking for would be what? What's the least common multiple of 3 and 8? 24, yes. So that number will be a little bit bigger because like the first one you have to multiply by 8, the next one you have to multiply by 3. So it's up to you. Please take a few minutes, try letter C, eliminate one of the variables.
Sorry, I think so.
It was just for a second. You've been pretty good. One should be negative, one should be positive, yep. No, you shouldn't get a decimal slicing. No, it's not. So the original problem is plus 8y and you wrote minus 8y. So this one you can also multiply by this positive 3. So this should have all the numbers that will be opposite. Thank you. All right, let's go over C to see how we did. So, what did we eliminate last time? Did we eliminate y or x? I feel like we did x. So I'm going to do y this time so that we can switch it up to see that it doesn't matter what you eliminate.
Last time?
Yeah, what did we do last time?
We did x and then y.
We did x and then y? Okay, well, we'll start with y this time. So I'm going to eliminate y, which means I'm looking at the negative 3, and I'm looking at the 8 coefficients of y, and I need these to get to the same number, but opposite. So the least common multiple of 3 and 8 is 24. So I need to take these and turn the whole entire equation bigger so that this actually says negative 24. This first one, I want this one to say negative 24, and this one to say positive 24. To do that, I would take the whole equation in the first one and multiply it by 8. And to the second one, I would multiply every single thing by 3. So when I do that, everything's going to be getting either 8 or 3 times larger. So for the first one, 8 times 4x is 32x, minus 8 times 3 is 24y, equals 25 times 8 is 200. And then 3 times negative 3x is negative 9x, 3 times 8y is a positive 24y, and 3 times 10 is 30. Now, when I go to solve this problem, I'm going to be adding straight down the line because I have a negative 24y and a positive 24. When I add those things together, they're going to cancel out. So when I get the 32x minus 9x, that's 23x, equals 200 plus 30 is 230. And when I divide by 23, I'm going to get x is equal to 10. So I know my ordered pair is going to be 10, comma. Now what I will do is figure out the y value by taking 10, replacing it in for x, and solving for y. You can choose whichever equation you want to use. I'm going to use the second one because I feel like I've used the first one a couple of times. So negative 3x plus 8y equals 10. We just found that 10 is equal to x, so I'm going to replace 10 here in for x, and then solve for y. Negative 3 times 10 is negative 30. I would add 30 to both sides. I get 8y equals 40. I divide by 8. I get y is equal to 5. Once you solve, then your last step could be to just verify that it works by replacing in 10 for x and 5 for y to make sure that it does work. 4 times 10 is 40, 5 times 3 is 15, 40 minus 15 is 25. The first one works. Negative 3 times 10 is negative 30, and 8 times 5 is 40. Negative 30 plus 40 is 10. The second one works. I know that 10, 5 is the solution. Okay? That is just one way to solve it. If you solved it differently and you eliminated your x values, then your whole process will look different. The answer will remain the same. So sometimes weird things happen when you solve systems of equations with elimination. So looking at this first example here, letter A, I'm going to eliminate x. So I see a negative 2x up top and a 4x on the second one. So I'm going to take this first equation and multiply everything by 2. When I do that, it's going to become negative 4x plus 12y equals 2 times 3 is 6. And I'm going to use elimination to eliminate it with the second equation, which is 4x minus 12y equals negative 6. When I go to do the elimination step, weird things happen. Negative 4x plus 4x cancels out like I thought it would, but so does the 12y and negative 12y. So this whole left-hand side of the equation, there's nothing left, so it's just 0. And 6 plus negative 6 is also 0. So sometimes this will happen with elimination, and when you get equations and you're left with nothing, basically, but it's a true statement, like 0 equals 0. This means that these two equations are the same exact equation, which means that in a system of equations, the solution is infinite solutions. These two lines are identically the same, which means they intersect at every single point. So if the variables all cancel out and you're left with 0 equals 0, then that means that it is infinite solutions. Something weird is going to happen with the next one as well. So this one's not as easy. I have to multiply both of the equations by a number. I'm going to eliminate x just because 3 and 2, I can see 6 instantly. That's a nice, easy, small number. So I'm going to multiply this whole thing by 2. And so that they're opposite, I'm going to multiply this whole thing by negative 3. I like the numbers to be opposite so I can add them, but if they're ever the same, you can actually just subtract and get the same thing either way. So when I take this and multiply it by 2, I get 6x plus 18y equals 16. For the first one, and for the second one, it would be negative 6x Plus negative 18y, I'm just going to put negative 18y, equals negative 3 times 7 is negative 21. All right, so when I go to solve this with elimination, I was eliminating x, but again, the same thing's going to happen. 6x plus negative 6x is 0. 18y plus negative 18y is also 0. But on the right-hand side, 16 minus 21 is a negative 5. Because 0 does not equal negative 5, what do you conclude this solution is?
No solution.
Correct. This is a no solution problem. So when you're left with something that's not true, that means that these two equations are parallel. So they have the same slope, but they have different y-intercepts. They never cross, which is why you get a false statement in the end. One more thing we have to do today before we can call it a day and before you're going to be prepared for your web assign, and that is a word problem. Please flip us over to example 3. Word problems for systems of equations are not going to be as fun as maybe word problems for just an equation or word problems for an inequality, because now we have two equations we have to create. So sometimes when we have more than one, like just one alone is difficult. Now we have more than one, so this is going to be tough. The problem says, a fundraising dinner was held on 2 consecutive nights. On the first night, 100 adult tickets were sold. I'm going to underline that. And 175 children's tickets were sold for a total of $937.50. On the second night, 200 adult tickets and 316 children's tickets were sold for a total of $1,790. Find the price of each type of ticket. That's what they want us to do. Find how much each ticket costs. And there's going to be a separate cost for children and adults, which is usually that way. Usually adult tickets are more expensive than children's tickets. So I can tell from that there's two variables and two things we're trying to find. We're trying to find the price of an adult ticket, so I'm going to let X be the price of adult tickets. And I'm going to let Y be the price of children tickets. So if that is the case, when I'm creating my two equations, one equation is going to deal with the stuff from the first night, and the second equation will deal with the stuff from the second night, from the dinner. So the first night, 100 adult tickets were sold. So that would be 100 times X, since X is the price for each adult ticket, plus 175 children's tickets were sold. That would be plus 175Y, equals their total from night 1, which is $937.50. And then my second equation would be very similar. I would just use the other numbers from night 2. Night 2 was 200X, since 200 adult tickets were sold, and 316Y, since 316 children tickets were sold, and that total from night 2 was $1,790. We can include the zeros or not, doesn't matter at the end. So we're going to solve this system by elimination. To solve this system by elimination, we have to decide what variable to eliminate. Looking at all of these variables, what's the variable that's easier to eliminate? Yes, X, because I see 100 and 200. I can take this first equation and take the 100x and turn it into a negative 200x by multiplying everything by negative 2. So that's what I'm going to do. Multiplying everything by negative 2, I will get negative 200x, and then this will be minus 350y equals, I don't know what this is, negative 1,875. And now that I have that equation all multiplied by negative 2, I can add these straight down to eliminate x, since negative 200x plus 200x is 0. Then I would add everything else straight down. Negative 350 plus 316 would be negative 34y equals negative 1875 plus 1790 is negative 85. And when I divide both sides by negative, this will start to make sense. Thankfully, a negative divided by a negative is a positive, because it would not make any sense to have a negative answer for a price of a ticket. ticket, negative 85 divided by negative 34 is 2.50, or 2.5. In this case, I know this is money, so I'm going to add the 0 there. That means the price of a children's ticket, since that's Y, is $2.50. Now we need to find the price of an adult ticket. To find the price of an adult ticket, we will now take 250, pick an equation, and put it in for Y. I'm just going to choose the second equation because there's some space here. So this will be 200x plus 316 times 250 equals 1790. And then I would solve this. 316 times 250 is 790. So I get 200x plus 790 equals 1,790. When I subtract 790 from both sides, I will get 200x equals 1,000. And when I divide by 200, I get that the price for each adult ticket is $5. Okay, so there's not a lot of space here, but the final answer in ordered pair form would be 5, 2.5. But it's important with word problems that you tell me what it means with words. So it's important that somewhere I see that it's $5 for adults and $2.50 for children. And the reason why that's important is because depending on what you choose X and Y to be, your answer ordered pair might be backwards. If you chose Y to be the number of children tickets and X to be the number of adult tickets, your ordered pair will actually be 2.5, 5. So it's important that you tell me exactly what the answer is because sometimes your answers will be backwards.